Hi, this is Algebra 1, Lesson 79. We're going to talk about systems of equations with subscripted variables. We're starting on page 323. Coming soon to an algebra lesson near you, you will be solving systems of equations dealing with distance, rate, and time. Distance equals rate times time. You need to remember this. You are actually going to use this formula in real life. I promise. Okay, so distance equals rate times time. You can figure this out if you know that rate is speed, and we measure rate by miles per hour, right? Miles per hour is the same as miles over hour, right? Miles is distance, hours is time, so rate equals distance divided by time. Rate equals distance divided by time. Okay? When we do these equations, we're going to be using subscripted rates and times. So, for example, if we're talking about a guy named Mike and we talk about his rate, we're going to say rate of Mike, or R sub M. If we have Joni, then her time is going to be time subscripted J, time of Joni. Okay? So when we see R sub M or T sub J, this is rate of Mike and time of Joni, or whoever. Okay. Solve the following system of equations for rate of A. So we'll call A Annie, and we also have P's, so we'll say Peter. So we have the rate of Peter and the rate of Annie. Okay, so here's our first example. We have the rate of Annie times the time of Annie plus the rate of Peter times the time of Peter equals 320. The rate of Peter equals 50, the time of Peter equals 4, the time of Annie equals 3, and we need to find out the rate of Annie. Now, you remember that rate times time equals distance. So this, rate of Annie times the time of Annie, is actually the distance of Annie. And the rate of Peter times the time of Peter is actually the distance of Peter. So if we were putting in units, and it didn't give units, so we're not going to actually do it, but if we were, and if rate is miles per hour, assuming rate is miles per hour, that means the time is hours, and this is going to be distance. This would be 320 miles. I guess that's actually meters. There you go, miles. So rate times time is distance. Okay. So we're actually solving for the rate of Annie, and we have the rate of Peter, the time of Peter, and the time of Annie. So we're just going to plug in all of these into here and then solve for rate of Annie. So we have the rate of Annie, which we don't know yet, times the time of Annie, which is 3, plus the rate of Peter, which is 50, times the time of Peter, which is 4, and this equals 320. Okay, so we have 3R sub A plus 200 equals 320. Let's get the 200 over here. And we have 3 times the rate of Annie equals 120. Divide both sides by 3, and the rate of Annie equals 40. Okay, once you set up the problems, the rest of it is just an algebra problem. Here's another one. We're going to solve for, let's see, we've got T's and R's. So we'll say the time of the rabbit and the time of the turtle. Okay, so the rate of the turtle times the time of the turtle this is the distance, plus 120 equals the rate of the rabbit times the time of the rabbit. So this means that the distance of the turtle plus 120 is the distance of the rabbit. So the rabbit went 120, whatever the units are, farther than the turtle did. The rate of the turtle is 2, the rate of the rabbit is 10, and their times are equal to each other. Okay? So we're going to substitute all of this into here. We have the rate of the turtle is 2, so this is 2 times the time of the turtle, plus 120 equals the rate of the rabbit is 10 times the time of the rabbit. Okay, this is all very nice, and we can get all the t's on one side. The problem is we can't solve for just one as this stands. But if we look here, it says that TT equals TR. So the times are actually the same. So we can substitute a TT for this guy, and they get all the numbers on the same side, and we should be able to solve for the time of the turtle, which is also going to equal the time of the rabbit. So let's say 2 times TT plus 120 equals 10 times TT. Because the times are the same, we're just going to substitute. Alright, now let's get this guy over here. And we have 120 equals 8 time of the turtle. We're going to divide both sides by 8. And the time of the turtle is 15. If the time of the turtle is 15, then the time of the rabbit is also 15 because their times were equal. So in the time that the turtle went its distance, the rabbit in the same time went 120 units farther. Okay, solve the following systems of equations for t, the time of L, and the time of S. So let's say we have Larry and Sam. The rate of Larry times the time of Larry, this is the distance of Larry, equals the rate of Sam and the time of Sam. So their distances are equal. They went the same distance. Larry's rate is 40. Sam's rate is 80. Sam's time is Larry's time minus 5. And we want to solve for the times. So we're going to start by substituting the R values into the distance. So we have the rate of Larry, which is 40, times the time of Larry. And this equals the rate of Sam, which is 80, times the time of Sam. Okay, this is what we have now. And now we can substitute this. So the time of Sam equals the time of Larry minus 5. So we're going to leave this side as it is and say 80 times, and we're going to, for the time of Sam, we're going to substitute this. And now the only variables we have in this equation are the time of Larry, and we can solve for that. So we have 40 times the time of Larry equals, we're going to multiply this through 80 times the time of Larry minus 80 times 5 is 400. Okay. Let's get this over on this side and this over on this side. So we have 400 equals 40 times the time of Larry. We divide both sides by 40 and we get the time of Larry equals 10. Okay, if the time of Larry equals 10, then we can find the time of Sam by doing the time of Larry minus 5. So that's 5. Okay, so it took Larry 10 hours at 40 miles an hour to go the same distance as Sam, who only took 5 hours at 80 miles an hour. Okay, here's another one. Now we have, oops, sorry, this is an F. Solve the following equation, solve the following system of equations for rate of F and rate of E. Hi, kitty. You're not an F or an E, but you are in my way. Go away, browser. Silly kitty. Okay, fine, you sit there. You're kind of a problem. Here, move your tail. Move your tail. Okay, I'm going to move the paper over here. Silly boy. Okay, we have the rate of F times the time of F. So this is the distance of F, which equals rate of E times the time of E. So their distances are the same. The time of F is 16. The time of E is 12. And the rate of E equals the rate of F plus 15. Okay, we're going to solve this for the rate of F and the rate of E. We're going to start by plugging in the times into the distances here. So we have 16 times the rate of F, which equals 12 times the rate of E. Now we can substitute this, and we already have rate of E equals. So when we see rate of E, we're going to substitute that. So we have 16 times the rate of F, which equals 12 times the rate of F plus 15. Multiply this through. 16 times the rate of F equals 12 times the rate of F plus 15 times 12, which is 180. Subtract both sides by 12 times the rate of F. And we have 4 equals the rate of F, 4 times the rate of F, which equals 180. Divide both sides by 4. And the rate of F equals 45. Okay, if the rate of F equals 45 and the rate of E equals the rate of F plus 15, that means the rate of E equals 60, because that's 45 plus 15. Okay? Hope you can see all that. Silly kitty. You're a silly kitty. That's it for this lesson. Try the practice problems in your homework and let me know if you have any questions. Thank you. You can't sit there. Did you know that? You're kind of in my way. I have papers here you're sitting on. These papers need to go under your feet. You're going to have to go somewhere else. Come on. Off you go.